people make or attempt to make an advantage out of necessity. If you have a big piece of iron that is I/O capable, and you want to sell it into a realm like VDI, you have to amortize a lot of work for platforms that are, you know, come in discrete styles at $400 a pop. It is a tough job. And so you configure enough of those machines to amortize your hardware system, and you call the whole thing enterprise, and you got a winner. And it's not untrue. I mean, no criticism intended for these guys. I understand where they're coming from, and I understand what they're trying to do. Problem is this is a technology that hasn't even started yet, despite what the analysts are talking about. It's going to start small. Most practical implementations are not going to be of 5,000 VDIs. They're going to be of 100 or 200 or 300. They're going to have to fit into the human organizational structure that already exists. It is not an either-or decision whether you're going to adopt VDI for a corporation of 50,000 people or for a front office of 50. There has to be a smooth transition between them. Our entire objective here was to talk about architecture first. And architecture has to be able to scale downward first and foremost. The scaling upward is always interesting, but practical computing platforms have to become human-sized first. Otherwise, they never become adopted. They're the realm of the gigantic national labs or huge insurance companies and have little relevance for most other people. So first attempt was to scale this thing down. Scaling it down means, in our case, sharing the hardware. Turns out in this benchmark that when we share the hardware, we get many advantages of locality, of reduced latency, that more than make up for using the same resources for 2, 3, 4 masters. But the scale down issue is the key issue to the introduction of any technology in our space. Having done that, scaling down also implies abstracting away all of the specialized components, hardware, software, etc. So it doesn't help you if you are able to scale below standalone controllers, if you then adopt SSDs or hybrid drives or some other variation on a theme. Has to happen based on standard components. Often that's what's available, but even more importantly, that's what's understood. Everything else is a multiple. The reason that common components always form the baseline is that they're the most understood because they're the most available of all computing components. So you have to start at rock bottom. I don't trust, personally, and I'm a CTO of a software corporation, so you know, I'm more trusting than most here. I don't trust brand named, brand part numbered exercises in computing architectures. I don't think most people do, right? So we have to be sympathetic to our customers. We tried to do 3 things with the benchmark. First, we tried to actually use a benchmark. One of the problems here is that many vendors have been rolling their own. They've been creating their own benchmarks. Without commenting on whether their benchmarks are valid or not, there's no comparability there. Certainly, virtual desktops are an understood application with known requirements. But the known requirements are available from trace data and from raw I/O counts, which don't really describe the characteristics of the environment you're trying to benchmark. So the result is a standardized benchmark is required. There really isn't one. The closest to it is the VSI benchmark from Login Consultants. Our next door neighbors used it and we're happy with it. Our next door neighbors are Citrix, so we tried it. We were fairly impressed with it. It probably does too much work per desktop and is probably a little too aggressive I/O-wise. but it is normalized and reasonable and covers a lot of the problems associated with VDI that we were aware of. So standardized benchmark is it. Why are you running a benchmark if you don't want to compare or measure, right? I read a lot of papers in the industry and it says XYZ virtual desktops and says they ran their own benchmark, and I don't know what that means. So that was the first thing, is to create measurability and a common standard and understand what we're talking about. The next was to get away, abstract away from all specialized hardware. We're talking about the application here. Of course we're touting DataCore. We run like a bat out of hell. I mean, and we want to show off. But showing off on some screwy thing that we made up is not useful. We need to go to standard components, which means standard server components with standard components inside them, which at this day and age means SATA drives and simple configuration, so that people can understand the multiples. They know the difference between a SATA disk and a 15,000 RPM fiber channel disk. They know the difference between SSDs and hybrid devices. These become multiples of common standard, so we were very focused on that standard. A lot of the gamesmanship that's associated with benchmarking doesn't apply in VDI, because you're trying to get to a threshold price, right? It's a pretty fair bet that the cost of $1,000 per virtual desktop isn't going to cut it here, because a discrete desktop costs $400. And whatever advantages it may have, there's a serious penetration problem associated with $1,000 desktops. In line with the previous conversation, and demonstrate those in practical configurations at the low end. Demonstrate the ability to scale downwards, not just upwards, right? So downward scaling here means you have to not only demonstrate low cost, but you have to demonstrate low cost in relatively few units. So we chose as a mark between 200 and 300 units, because that seemed like reasonable numbers. And it's what can usually be accommodated by the smallest high availability pair, right? The scaling exercise then becomes growing the high availability pair to larger numbers, and we talked about that at great length, right? The other side of that is to do that in an environment where you're not using so many special features of this or that hypervisor or this or that hardware configuration that only you offer, or whatever, so that the sizing game is not a game. It's an actual sizing exercise. So that was the next part of it. We wanted to blow the numbers out of the water. The lowest numbers we'd read out there was about $50 per desktop for 5,000 desktops. Now, the $50 per desktop, that was for storage hardware costs, right? The $50 is kind of reasonable, but you add the hardware to run the virtual machines and so on, it starts to crank up a bit. You add the software, it cranks up a little more. $50 is sort of in the ballpark. We thought 5,000 was a ridiculous number, or 3,000, or even 1,000. You need to get way below that on relatively few bite-size configurations. And so we went for an objective getting below $100 hardware and software-wise at 200 to 300 desktops. We achieved just under $70 at 220. And storage hardware costs became inconsequential. They almost don't count. So, not bad.